Hello, everybody, and welcome to Handmade Hero Show. We code complete game live on stream. So today it will be kind of interesting. We have to start figure out how we want to connect up dungeons. We sort of did some. Well, you know what? I'll just show you where we're at here. It's really just about us thinking about how we want to design overworld levels, and again, not really my area of expertise, so. Hard to say how we want to do a lot of this stuff, but the current status of the game, as you can see, is we had, like, you know, the orphanage and the areas around it. We trapped the poor hero in this little tiny room for a second while we start to do overworld layout, and we did some sort of sparse overworld layout stuff where we can specify that we want these rooms to be sort of, in fact, you know what? We should make those a little thicker, shouldn't we? Like, I feel like in here we should maybe have drawn those a little thicker. There's like a thing that draws rooms, I think. I don't actually know what we set that to or why. But like for some reason they seem very not thick. So let's try making them thicker so that they're easier to see. Because I think that would probably be good. There. It's just easier to see, especially on the stream where this might, you know, be kind of compressed, all compressy. So essentially what you see here is we tried laying out some things using various algorithms that sort of like that had certain constraints about where things should be placed. And this is just an example of a run. We can, you know, run it as many times as we actually want so here's another rerun of it, right? And you can see they place in different places. We don't have any strong reason to prefer anything in particular right now because we're just starting on the, like, designy sorts of stuff of the game, which is not, like I said, not my thing, so I don't really like it, and I don't really want to say much about it because I don't know. But we just have to do it in order to say that the game is done, so we're doing it. So I you know, put in some generator stuff that would basically lay these things out in ways that were non-overlapping, so you can see that these squares would never randomly pick things that will overlap each other, right? And then it will place them in like a certain sort of in a way that matches a few constraints that we thought might be what we would want. And we don't really know, but, you know, we just have to pick something to get started so we can start sort of playing around with how it feels to traverse the overworld and get to a dungeon. Since that's the first thing the player will experience, we kind of want to, you know, start experimenting with that and see where it leads us. You can see that the dungeons, which are shown here, I believe, in yellow, are placed sort of, they're not necessarily equidistant, but they're in a sort of distance band away from the starting area. So you have to traverse a little bit of the world to get there, but not too much. We don't want you to have to, like, travel really long distances to get there, or that might make the game kind of crappy. And so, you know, but they're in sort of a band so that the player can expect that they're sort of out in a relatively constant sort of distance from the center as they're exploring. We then have some item rooms, which are sort of things in the overworld. There obviously will be, I assume most of the items that you get in the game, or like power-ups, will actually be more inside the dungeons themselves. But there should be some, instead of item rooms, let's just call them like special rooms. I felt like there should be some things occasionally, like a fairy fountain kind of thing in the Zelda, or, you know, whatever, or a chest that you get. I felt like there should be some of those in the outer world, so we had some stuff that lays those out as well. Those are the blue. And then we sort of had this idea that there might be particular locations that pertain to how monsters work, where, like, maybe the monsters sort of originate in these locations, and the monster type of that, like, originator sort of, it means that you'll find those monsters, like, in a region. There might not actually be anything in this square, so in a sense it's a little bit less like the other things that we're saying overtly you would, like, actually walk into and there would be something there. but it's more that like they are things which will determine which monsters we place in various regions, such that the overlap between them, or the distance between one of them and some other type of room would sort of tell us whether or not monsters of that type, whatever that is, would appear in that room. So for example, this monster like originator kind of thing over here, we would expect not to affect any of the game that happens over here, and vice versa. So again, these are just very loose things, and it's just to give us something to start playing with. We want to just make a little bit of a game sort of experience here that we can play with for the express purpose of learning what might be fun or interesting. So what we want to do now is start to create paths that connect these things together. And this is a little bit of a difficult thing for us to do because, again, we don't really know what we're doing here design-wise, right? Like, that's the problem with being an engine programmer, is when you get to this point, if a designer told you to do something specific, then I can go, explicate the design, the architecture that produces that. I can go experiment with it or create it, right? But what we sort of have to do here is do something purely to give us a starting point. Because we don't even know what that design is or what we might want to do. And so when we look at this, what we want to ask ourselves is, well, I guess what's the simplest thing we could do that creates some kind of paths, no matter how crappy they are, in between these things, so we can start to feel like what it might be like to traverse among them, and then start to populate these actual rooms with things. So, put an actual dungeon entrance, although it won't go anywhere, at the dungeon entrances. Put an actual item like thing that you can get like a pickup or something in the item rooms. And then try to make it so I can traverse this world, right? That's basically it. Am I using compute shaders? What? I mean, the answer is no, but I guess I don't understand the context of the question. There isn't really anything in the game right now that we would use a compute shader for. Anyway, for the rendering, no, it's this uses a simple rendering path that should be able to run on most hardware. Like, this is not, it's not using anything odd. So anyway, the point is, this is where we're at. And so I need to produce some kind of a strategy for this, and I don't know what it is. So what I would want to do, I guess, I mean, I really just don't know, right? But what I would want to do, I guess, is sort of say, well, we need some idea of like a connectivity graph, like, of these things, right? Like, we need to know, like, if I'm going to generate paths between these things, then I would need some way of knowing whether or not I should be able to walk between two of them, right? Like, if there is a path, if I imagine, like, connecting these things together semantically. So maybe, for example, like, maybe we run a post pass on this thing where I create like a little edge structure that connects these things up together. And then I just say, well, maybe I can just like create paths between the ones that have connections and then don't create paths between the ones that don't, or something, and we'll consider that just sort of a good enough first pass, right? That might be sort of what I would say. What is going on in the chat right now? I've been trying to read chat more lately. However, it seems like the chat has gone off the rails. We're asking about compute shaders in SIMD. I have no idea what. Yeah, I don't really know what's going on in there. Let's just remember a couple things about this. So compute shaders and SIMD are the same thing. A compute shader is just SIMD that you run on a GPU instead of on the CPU, right? They're the same thing. There's no difference between those two. They're both SIMD. GPUs are SIMD. GPUs use wide execution units. Usually they're like 32 elements wide, usually float. 32 floats wide. It's the difference between that and the PC is usually 8 elements wide, 8 floats wide. But it's the same thing. The programming model is a little different because you write scalar-looking code, but that has to be executed in groups, bundles of 32. When you're talking about compute shader, you write it manually as when you're dealing with SIMD on the PC, because that's just the programming model for the compiler. These are all arbitrary things. The processors are very similar, right? So, that it's not so much those questions are off topic. It's more that those questions were difficult to square. Like, I'm not sure what they're talking about, right? Like, and furthermore, compute shaders are only necessary if you need to write data in an unordered fashion, right? So, like, you don't really need a compute shader for rendering. You can use one for rendering if you need to write in an uncontrolled fashion, but you don't actually need them if you're writing in a controlled fashion. You can just put it in a pixel shader if you want to, right? There might be reasons why you wouldn't want to, but et cetera, et cetera. So, yeah. So, let's just, hopefully that helps. Okay, so what I want to do here is basically create the overworld map, and I'd like to make it so that, to at least some extent, we have like a, what by the way, what was that crash from? I couldn't tell, like, we got a crash in the 999. It's not actually a crash, it's just an assertion that lets us know that it wasn't able to place something where it wanted to. Does that mean that occasionally it can't place things, or is that like a spurious, weird crash? Here's me running the generator like an infinite number of times. Looks like I need to upgrade my remedy BG. Like, I don't know what's going on there. I can't seem to. I guess you can't. With that, I don't know. I can't see this because my head's there, so I'm gonna move this over into here, so it's a little easier to see. Anyway, it looks like we overflow the debug record boundary is mostly all that is, which is fine. The debug system really sucks in Handmade Hero. It's one of the worst things. But that's, just an assertion, so I guess, I don't know. I guess, I'm not sure what that sort of assertion was on the 999. I'm not sure how we provoked that. I don't really know. So that's a tough one. So anyway, I don't know how we want to approach this. I'm not sure what the best way would be to like make forward progress on it, because I don't really have a strong opinion there. But I do know that like I said, we need some idea of like how these things are going to be connected. So maybe we want to just kind of like cluster them up once we have them placed, and I don't know, like. I really just don't know. It's very tough for me to think through because, like I said, I don't, it's just not my thing. This is why I don't design games, right? Like, it's not my thing. I don't really like it, and I don't have a knack for it. It's not really that. It's more just, I think you're good at things you enjoy doing, and I don't enjoy, like, non-engineering style things like that. I don't know why. I just don't. So, what I would say here is I guess I'll just go in and I will try a couple ways in which we might want to connect things to each other. And I will see if those things produce graphs that I think would be like what I might want game-wise. And there probably should be. So one thing that we didn't do, and I think I will do before I do that, is there probably should also be the concept of rooms that are there simply to create a superstructure, but which do not have any actual, like, specific gameplay purpose other than waypointing, right? So, like, in other words, if you look at these, if we were to connect all these rooms to each other, all of the, let's just suppose that all of the paths in this forest that we're creating are strictly paths in between rooms that mean something, meaning dungeons, monster centers, or these like special rooms, right? If you only have those, it means there will never be things like a fork in the road that's just a fork in the road, right? And so the other thing that I think I might want to do is place what I would call navigational centers. So these would be nodes that do not have a meaning in the gameplay sense, in the sense of a physical gameplay object that the player needs to know about, but they would perhaps, like, they might have a statue in them or something. They would serve as like a waypoint for the player. Like, here's that part of the world that I branched off of or whatever, right? And so I think one more thing that I wanted here is to say, all right, in addition to these things, we would have like a nav room, which is a room that is there for the overworld just to have this, that's basically what I'm saying. So we'd have a nav room, and it's the same as all the other rooms at this point because we're not really creating specific rooms, but eventually it will have something different. So I am going to make a different function call for it, create nav room. And we will place these down to further our worldnesses. What are the colors that I'm using right now for things? So maybe these will just be green, right? Like the forest. They'll be green like the happy forest. So we'll create these nav rooms, and those will serve as like waypoints. Again, I'm just making things up here so that we'll get somewhere. I don't have a plan. Do not expect me to design a game, so I'm not going to do it. So when we create this stuff, we will now need to place those rooms. And looking at this, what I think I would like is just anywhere that there aren't rooms, we would place these rooms, right? So I think my basic idea is just that it fills in some of the gaps in the world with these extra rooms. And so if you look at the... jump to the create world thing here. So when we do, I guess it's layout overworld, you can see us placing some of these things. We placed each one of these monster generators and, I don't know, other crap. I will now add yet another thing here, which is nav room count. And this will be like, yeah, some kind of a generate random between. And I don't know how many there should be, but it probably is actually similar to this. Like, it probably should be parameterized off of the number of other things. So, maybe the maximum is that and the minimum is some small number. Like, so the maximum, it will never have more than, like, the total number of actual things out there, right? Because we don't want lots of connections. So you know, in a sense, I wonder, this may even be like too high, so I don't know. But something like that. And then I'm going to place these at the end. So what I would want to do here is say I'm going to place nav room count rooms. I do not care what the min and max distances are, really. And they can be placed like, yeah, I guess within this, within 60. And, you know, the problem with this structure of the code, in a sense, a little bit, I may want to have a way of saying, look, if you can't find a place to place one, that's fine. Because this is going to probably not be able to place... It's probably not going to be able to, like, fit this in there. And that's actually okay. I probably just want to try a few times and give up. So what I'd like to do is basically say place as many as you can, which we don't currently have. So we're going to hit that 999 check. If we do this, basically, this one right here. You see I did? And if we go out and look at the overworld, I'm guessing that the placed count here, which I probably can't look at because debug inspection is always terrible in release builds, I'm guessing we placed a few and then we couldn't place any more, right? So I don't have any clever solution for that other than just saying when we pass... When we call this function to do the analyst placement, I guess I'm gonna say that the analyst, maybe just has a thing in it that's like require placement, something like that, because I don't want to have to assert every time. I just don't know. Let's take a look. So when we do pick point in analysts, you can see that it does the assertion here. Maybe, you know, maybe this wants to be a thing where it actually just does an if, and this should actually have been a Boolean. You know, I don't really know. Like, it could be that the better way to do this would be something like pick point in analysts returns you whether or not it picked the point, and then you decide what you wanted to do there, like whether you thought that was good or bad. And so I'm tempted to say that, like, there's a world gen pick that's like the P that got picked, and like there's like a valid as to whether or not this thing actually worked. And so, you know, we have a world gen pick v2, and the world gen pick v2 is like a result that we go through here and create. So the result.p is what we actually look at in these two. And then we say, with this past filters thing, instead of having past filters, in fact, you know, now that I think about it, maybe that's what we do. Like, we just have past filters is a thing that you set and return. So the past filters part means we don't like need this assertion anymore. We just try a bunch of times to see if we can pass, and if we can't, we just tell you we can't, and it's your decision as to what you actually want to do with that. So we can say, okay, we get a placed P here. We can assert on placed P past filters, like so, for the ones that we care about, and then we just used the placed, you know, maybe instead of that, I'll call this pick like that. You know what I'm saying too? And this way, we can assert the ones that we think we actually care about whether or not they got placed. And then if other ones were just sort of saturating the world with some of these things, but if we can't place them, it's no big deal, then we don't end up in the situation where we have to like not assert something we actually wanted to assert because sometimes we don't want it. We can always assert it in the cases where we wanted it and not assert it in the cases where we don't, which to me seems like a better strat. So that's my story, and I'm sticking to it. And if you don't like it, well, you know, this is why I say that we don't do game design here. So unlike with programming, if you have complaints, I ain't going to listen to them. That's not my responsibility. So you have to go watch a game design. Watch somebody who streams game design. Ask John Blow what to do, and listen to him when he tells you. But don't come crying to me, because this ain't my job. All right. So here what we're going to do is when we get to the nav room count version, so hopefully all the rest of that code will now just work the same way, right? But in this version, we're going to say if it didn't pass the filters, right, then we just won't place it, but we also won't care. So we're not going to assert anything, because if we couldn't place it, then that just means we don't place this one, right? And that's it. Like we don't care. It's not a problem. It's not our problem. It's not our issue, right? Now, in the slight interest of expedience, we might also say that, well, if we couldn't pass the filters, then there's no sense in continuing to ask it and just burning CPU cycles looking for a placement that we probably won't find. We already know that we couldn't find it, so, we stopped trying. So hopefully now we will have a thing where we will place some of these rooms. Now we have to adjust this to fill them in. I might want them in some other areas, so the problem here is it might be requiring them to be too far away. So I would like a little bit more than that. So I think maybe this distance should go down. I don't know what it should go down to. 30 is one option. That actually looks pretty good. Again, we want it to feel fairly random. So we don't really want it to feel too perfect or packed. So we don't necessarily want to do stuff like fill in areas always. Like we want there to be weird areas of the map that are just you don't get to. And the reason for that is because we want there to feel like there's some sense of like mystery or difference like between the different oh, interesting. So here's one where it couldn't find a place to put a dungeon. We really need a better strategy. We need a better analyst picker than we've got, to say the very least, because currently it's kind of crappy. But anyway, you can see here a very like complicated world that got created, and you can see here that depending on what we do, we get different levels of complexity, right? You can see like this one's considerably simpler than the previous one, and so on, right? So, reasonable. And then what I'm thinking now is we go ahead and make some edges that connect these up. And what I would like here is I think what I would like to do is basically connect rooms to each other if the connection between the two rooms doesn't... Ooh, do I want that? I guess I don't really know what I would want the metric to be. I think what I would want the metric to be here is something like if two rooms are within a certain distance from each other. So if the rooms are within what we'd call like our connection distance, then we connect the rooms unless the connection would have passed too close to some other room. Maybe? It's hard to say because, again, what you're trying to do here is not really geometric, it's theoretical. Like, it's like the design will want... when we play the game and start to refine the design or think of ideas inside the design to the extent that we're going to have any, we will want to potentially change this. So we don't really want something super complicated here. What we want is something we can play with. Like, we want something that we can feel comfortable, like, tweaking around and messing with, right? So what we would like is something simple to start with that will connect these up in a way that we could then make decisions about. So I do think thinking of them pairwise is probably the right way to go, and then maybe preventing connections between rooms that would obviously go through another room is just a cleanliness factor that we would add in there so that the generation code that's like connecting these rooms doesn't have to think about things that are maybe a little too complicated at that lower level. They can just know that they're always dealing with paths that are unobstructed or something like that, right? So let's try. First of all, I don't even know, like... do we have a function for... yeah, okay. So we do have the ability to draw, like, a line segment. So, because, you know, we don't really draw... in the actual game, we don't have line segments, right? You know, everything's like a little, like, sprite or a 3D room, you know, or lighting or that kind of stuff. The game doesn't have any of this stuff. So it's just debug code. I don't know what debug code we actually have. So it looks like we have line segments... and so maybe what I'll do is in the world code nonsense that we have here, I'll just say, well, in addition to these world rooms, I'll just have connection count. And these are, again, they're not real. Like, these are just garbage things that we're throwing in here because we just want a way to draw this stuff. It's not real, and it wouldn't probably... actually, this will probably not survive these random arrays that are in here. They'll probably just get thrown away at some point during the development process. But, you know, for right now, I don't care. So they're just some things that I can use to store some data and look at later. And, you know, maybe they will survive later, but I doubt it. So all I'm going to do in this world, it's really just the basic, you know, standard edge style thing you would see anywhere else. Where in here, I'm now going to go, like, after this layout overworld thing happens, right, I'm going to go through each of these rooms, and I guess... I guess... I'm literally just going to say, for every room that we placed down, because here they are, right? So for every room that we placed down, I'm just going to say... look at all the other rooms that there are and see whether these two should be connected. So basic n-squared algorithm, we know that we only have a handful of rooms, like 30 rooms or something, so we can n-squared this all day long. We could n-cubed this if we want to. For those of you who are mathematicians, operating in any kind of a exponential way on these things is really just not a big deal, right? Even if we had to do a cubed iteration over all of these, we're talking about just nothing, basically, right? Like 27,000 iterations to a modern computer is laughable. it will laugh at you and tell you that it doesn't care. So in this particular circumstance, I think because we're dealing with so few things, there's also just no reason to be clever here. We should just do the most basic possible thing so that we can experiment with it. And then if sometime we want to optimize it because we want it to go really quickly and not the player doesn't wait for it if it turns out to be slightly slow or whatever, we can do those things. But I don't think we need to think about any of those right now because we have so few actual things that we're looking at that I don't think we're going to need to worry about the performance of this anytime soon. So I think what we want here is like a lock A and a lock B. So we would have a lock A index, and then the lock B index would always run from like this index forward. So it's only going to look at connections between rooms that we haven't already considered as a pair. And this is a pretty basic kind of thing that you do where you say, all right, we're looping over all the rooms, but then I don't want to add duplicitous connections, right? You want to just say, consider every pair once. So rather than it being a loop of 0 to location count twice, right? I'm doing a loop of 0 to location count and then only a loop over pairs we haven't considered by saying start after the current index only. Because we know all the prior indexes, we would have considered this pair on a prior run through the inner loop, right? So again, just a pretty standard loop construct, 0 to the count, and then whatever our other index is plus 1 to the count, means this way we know in here we don't have to check to see if we've already added a connection for this. We know we've never considered this pair before. Yeah, that went down the wrong way. So let's start with some garbage. Just absolute garbage. Bad. Terrible coughing. Don't like it. Do not approve. I like that little screamy face that someone just placed it in there. Can we get some more of those? What is that little thing? I don't know what that face is, but I like it. Can someone tell me what that face is? What's that face? Hover over it to get the keyword for the face. What face? We don't ever see that one on here for some reason. We see the lull one. The lull one people post occasionally, but I never see the what face. So we're going to have this world root connection. I think I'm going to stick the debug color in here as well. And I'm also just going to, I'm going to add, there's like an add world room. I'm going to add a equivalent call for add world connection. And this is literally just going to be the two, like what are the two rooms that you wanted to connect, and then the debug color. And I don't really know what we're going to do with this other than just draw it for now, but that's totally fine because like I said, that's really all we're trying to do here is get a layout that we can use for our, you know, our like lower level gen code to like figure out what the heck it should create. So this is the same code. It's literally just busywork code. You know, it's the kind of code that you shouldn't have to write, but you still do. You probably still have to write it in most of these modern languages too that suck. Maybe you won't have to write it in JAI. One can only hope. But anyway, here it is. Ooh, boom. I typed boom instead of room. So we can add world connections to this list, and then we can call that, this is going to be world room connection here, and we can call that, and I'm going to call that in the generator here to just add like every room that there is, to connect every room that there is. Like, I just, all of them are going to get connected to each other to start with, and the reason I'm doing that is just to see if this works at all, right? Because before I start thinking about how rooms should be connected, I want to be able to see them and ensure that they actually do get connected, right? And so, yeah, you can kind of see why, why I would want that, hopefully. So I'm gonna force it to add connections to all of these rooms. I'm just gonna make the connection color be a stunning purple, a lovely magenta, if you will. And then I'm going to, if we run it now, in theory, I mean, that should work fine, but we won't see anything. At least I don't think we will. I would be surprised if we do. We just have our standard thing. What I'm gonna do now is just draw those, so that I can see that they are there. Here's the, volume outline garbage. So what I'm gonna do is I'm just gonna go through here and say for the con indexes that are in the world, we are going to take the world room connection for this thing. And then we're going to pull out both rooms. So we have room A and room B. We know what they both are. And as you can see here, we then have some nonsense about drawing these things together where we map things into SimSpace and all that other kind of garbage. What I want to do here is, instead of drawing a rectangle, which is what we were doing before, and also, by the way, I have no idea how we actually draw a line segment in practice. Does anyone know how we might draw a line segment in practice? So it looks like we can just call this directly, and so that's what I'm going to do. So I'm going to draw a line segment here. I'm going to draw the line segment between the two centers of the rooms, I guess. Maybe. I don't really know. But that's what we're going to do. So we're going to say con debug color. That's how we're going to color the line. We are going to have a thickness that is some thickness, same as the room thickness, I guess. Maybe it should be slightly less, so maybe it's like half the room thickness. I don't know. And then what we want to do is map these things into SimSpace somehow. So in here, for example, you can see the min pose and max pose. So, like, what we could do is say, well, we've got SimSpace for each of these two things, so we can have, like, a thing where we map them in and take the blend of the two, right? So we'll just take this the middle of the room, if you will, of each of these rooms, and we'll draw it from there. So room A's and room B's center points are where we will draw, and we'll see if that works. We don't really know. What is the complaint? No overloaded function takes 5 arguments. One, 2, 3, 4, 5. Well, I don't know if I believe you. that does kind of look... Oh, no, that's 6. 1, 2, 3, 4, 5, 6. All right, I believe you. I believe you. I'm sorry I doubted you. Okay. So, let's see where we're at now. Are these... Oh, you know what? These debug colors, I think, need an alpha, right? They're only stored as 3 component colors as the debug color, and they need an alpha for the drawing system wants to know what the alpha should be, so we'll give it to them. Okay. So what we should see now, so actually, like, there's a bit of a weirdness going on here already that I notice, but it looks about right. So with the exception of one thing, that looks correct to me. Right, you can see, like, for any given one of these, you know, there's a line that connects to the 2 of the rooms, right? So that seems all right. This, on the other hand, is not right because you can see we're adding, like, 2 different rooms here. One of the rooms is a green room, and the other room is a blue room, and I didn't mean to do that. So there's a problem going on here where we add the room twice, and I do think I know roughly what's happening there. I think what's happening there is we have in the room gen code, you can see us add the room to the world here. And I just, that maybe shouldn't still be happening. We don't know, but we're using the system for something else right now, so I think I want to get rid of that. Okay, so now I think we've got what we expect, which is, you know, the spider web thing where each of the rooms is connected to each of the other rooms. And we can't really tell because there's too many lines and they might overlap each other and whatever. So we don't know exactly that this is working, but it's at least close enough that I'm happy to continue now, right? So now what I would like to do is actually put in a criteria. So instead of just forcing all rooms to always be connected, which obviously isn't helpful to us at all, what we want to do now is say, what are the actual things that we want, what are the actual criteria that we have to have in order for 2 rooms to be connected? And so one of those things, and if we look at what we have here, you can see we've got a storage that says here's where the room is. One of those things is that I said was I don't want rooms that are far apart. You know what I'm saying? I don't want, like, far apart to be like rooms that are far apart should not be connected. Just no, bad, right? So what I want to do here is check the distance between the 2 rooms. Like so. So if the length between A and B is less than some value, and again, I don't know what that value should be, but let's pick a random value, 30 for now, then I will add a connection between the 2 of them, and if it's not, then I won't. And that's all I'm going to do. So if the length is less than a certain amount, right? Oops, that's supposed to be a P. So that's the first criteria I'm going to add, and it's a very simple criteria, but, you know, it is what it is. And so off we go. I don't know why that didn't work at all. Oh, because I mistyped it. We were checking the distance of A to itself, which surprisingly turned out not to be very far. So here's all of the rooms that are within that distance, and you can see it's too conservative. Like, most of our rooms are not within that distance. So let's try more up in the 60 range like before and see if that creates a reasonable number of connections. Okay. So now you can see that I think we actually have a good starting point here. You can see that some of the stuff that we've connected makes a lot of sense. Some of the stuff maybe perhaps doesn't make a lot of sense. But on the whole, this is closer to what I would have wanted, right? So this is pretty good. Honestly, I think this may just be fine. I mean, this like, so even just that simple piece of code basically produced what I wanted. So I think what we'll do now, really, there's just two things I'd like to add. So one would be that if a connection, do I even want that? That may just be fine. I think that's just fine. So I may just leave it. The only thing I want to add is you'll notice that sometimes it's possible, like with what you can see here, it's possible that a room, that an island can be formed where the room is not close enough. There is nothing within that radius of the room, and there is no other path to the room. So you end up with effectively a partitioned graph where some of the things are strongly connected so that everybody can reach everybody else, and then there's this not connected part, right? So I think what I would want to do there probably is not really mess with this, because this seems to produce the kind of connectivity I more or less wanted. Like this more or less produces what I want, I think. And we'll see. Like, I don't know if I want to remove like some of these things. There might be I might want a criteria that says that a connection between two rooms cannot pass very close to another room. So some of these might want to get pruned. But like, that is totally fine. Like, I don't really want to prevent connections from crossing. I think that's fine if they do. I just don't want them to maybe have that kind of closeness. I don't know. It might not matter for what we're doing. But I'm just going to table that for now, and we'll see what happens when we actually start to generate the actual geometry down at the lower level. Because right now, I'm just thinking maybe this is just fine. So what we want to focus on here is just something that at the end repairs any problems where if there's an unreachable part of the graph, it gets mandatorily connected, right? So there's a couple different ways we can do this. It's very straightforward to do. I think my gut feeling for how I would like to... there's a lot of ways we could do this. My gut feeling is the best way to do it would be do something called a disjoint set forest. It's a fancy term, but as you'll see in a second, it's very, very simple, actually. So So what I want to do here is say, okay, each of these guys that we're connecting, we now want to make a pass over all of the connections and go count to see how many of these individual like islands we have. And if we find that we have more than one, we want to find like the closest, probably would be my guess, the closest two rooms in the two islands and just force there to be a connection between them. So I'm assuming that this happens fairly regularly, meaning that most of the time when we start the game, there's some other island, right? And you can see there was one there. There's one here. There's one there, right? And so I think that really we just want to count them. This one didn't have any, but you know, that seems like the rarer case. Although neither did that one. So yeah, I guess, you know, it happens 60% of the time, 70% of the time. Yeah. So, yeah, again, my assumption here is just that I probably don't want to bother doing anything too fancy. So I think what I'd probably do is go ahead and start from the starting location, which is like at some point here we place down the orphanage, right? Here. So the 0 connection is basically just saying for each of these world gen locations, what I want to do here is have a like connected to orphanage Boolean, basically. And so we're not really going to do a disjoint set forest here per se. I mean, we sort of are, but I don't know that I'm going to bother actually doing a... Like, I don't know that we're going to actually bother doing a real disjoint set forest. I think what I'm going to do is in each one of these, I'm going to say, like, okay, location 0 is the orphanage. So here, you know, when we do this push location, we know this is the orphanage. We're going to say that the orphanage, by definition, is connected to the orphanage because it is the orphanage, right? And then what we're going to do is every time we add a world connection here, we're going to take, and if like A is connected to the orphanage, then B is connected to the orphanage. Another way to say this would just be to say that A's connected to orphanage equals like the combination of the two, right? Maybe we'll do it this way. So we OR together the two connected to orphanage statements, right? So, oops, that's supposed to be an OR, not an OR equals. Why is that indenting improperly? Does anyone know? Nobody knows. So every time we add one of these connections, we're just going to like mark the fact that we've connected these things to the orphanage, right? And we'll say like, yeah, if this is just a little, Well, yeah. So maybe we do something like this just to test it. I'm really just testing it. So here, if I go through all of the, excuse me, if I go through all of the connections in this thing, and I say that, if I grab out each of the connections and I look to see whether or not they're connected to the orphanage, so I say, a particular connection, it has two rooms, right? There's room A and room B, and then I set the connection's color. So instead of using that color, I basically say, like, okay, if A is connected to orphanage, assert that B is connected to the orphanage as well. In a sense, I kind of have to do this propagation at some point, so this will not quite be correct. But either way, this check will work. I'll show you what I mean in a second. So just make sure that everything's set properly, like we didn't mark something as being connected or not connected, if its posing room was or wasn't, right? And so what's going to happen here, the reason I say this isn't going to quite work, is because what's going to happen here is later connections in the set, we should see these fire. Because what should happen is, as we went through connecting these, we only satisfied the connection for just the thing we were actually connecting at that time. We didn't then propagate that connection forward. So we should hit these assertions immediately, in theory, yeah. So what we want to do is effectively flood fill. When we say that something's connected to the orphanage, we want to flood outward from those connections, propagating as many times as we have to ensure that we basically filled it out, right? So what we want here is to run this loop a few times, basically something like this, where we say, hey, keep doing a propagation on the connections in the rooms until you don't change anything. So it just kind of floods outwards, right? So we would say change something equals false. And then here we say if we haven't changed something, then we break. You know what I'm saying? So that's it. So then in here, what we would do is, while we are looking through the connection indexes, we would say if A is connected to orphanage and B is not, or the other way around, then we change something. And we say that it propagates. Now, we could just not do this, and in fact, maybe we just shouldn't. We'll just do the slow propagation because why not? And so everything will propagate inside this routine, if that makes sense. So when we run now, what we should see is that anything that was connected to the orphanage gets a white line, and anything that wasn't connected to the orphanage line remains purple. Now, everything was actually connected to the orphanage in that one, but here we go. Here's another one. So now you can see that we've, just by doing the simple propagation, we've detected correctly the islands. Of course, I guess we can't quite tell there. Maybe I should set the room colors to purple for now, just so we can make sure that we actually connected things that don't have something connected to them. So in here, we could say, okay, maybe instead of doing this, we don't actually do a loop over the connections here. Instead, we do a loop over the rooms. So we say for each room index that's in the world, although I guess they're the same. So I guess we don't actually need to do that. We could say, instead, for each room, or for each location, I should say. So like this code. For each location, what I want to do is, if the location is connected to the orphanage, then I want to change its world's rooms, like the room that's created in the world structure. I want to change its color to purple so I can see that it like ended up in an island and has been stranded, right? So I'm just going to say in gen world rooms, grab that room out and set the debug color to porpoise, like so. So now what we should see is a series of connected thingamies doing stuff. And then there's some purple rooms off to the side that aren't connected to anything. That's what we expect to see, right? What is the... Oops. What is the problem? That is supposed to be a 0. Not a lock index. And then these connections can just be white. So they're all just white connections now. We don't care about the color of the connection, and it's the rooms that will now be shaded purple. So off we go. Here we see no purple rooms because everything's connected. That's exactly what we would expect. Here, again, no purple rooms because everything's connected. Here, everything is not connected. That is wrong. So something didn't quite work. What did I screw up is the question. Oh. Wait, this should have set them all to purple. What happened here? Oh, what happened here is we haven't created the rooms yet. Oops. My bad. So that actually doesn't quite work. This has to happen after the fact. So this has to happen after we generate the rooms like here, right? If we want that to work. All right. So now let's try to get this working. This seems to think that nothing is connected to the orphanage. That doesn't make very much sense. If nothing is connected to the orphanage... Does that... I mean, I know I selected one of them. Oh, that's why. I had it set the opposite way around. All right. So now... Okay. Now we appear to be working, at least speciously. You can see that over here we've got an island. They're properly colored purple. We have all of the rest of the things connected. They're colored the correct colors, and they're connected by white lines, which is what we would expect. Here, everything's connected except these two, and they are purple. That's what we would expect. So it seems like we're doing the flood fill properly now. There's no islands, and everything looks fine. And here we have like a really good example of a weird kind of dungeon layout, right? Or I shouldn't say dungeon layout. Overworld layout. That all looks good to me. And so I think the next thing I want to do is just fix those islands. So after we do this propagation, what I want to do here is we want to do these propagations in ways that allow us to figure out there's kind of a more efficient way we could do this, but I'm not sure I care. So what I would probably do here is say, all right, as we do our gather, this is the propagation. And in here, we would look for things that aren't connected to the orphanage. So we would say, in a similar way that we did before, basically this colorizing routine here that we were doing, we would sort of do that, only slightly differently. So what we would do here is we'd say for each location in the game, if this location is not connected to the orphanage, then what we want to do, in fact, I guess what we want to do is figure out what the closest thing is to the island. You know, so if you have an island or two islands basically, one that's connected to the orphanage and one that's not, you want to find the closest point and draw a connection. Now, is there a real reason why I have to do it that way? Not really. I just think that would create the most plausible maps, right? Hello, DM Viper, and welcome to the stream. So what I'd like to do here is when I grab each one of these things, I want to say if this is not connected to the orphanage, let's see if it's the best thing that's not connected to the orphanage to connect. So I'm going to do like a min-con dist thing where I basically say, all right, there's a connection that we're going to do, min-con index, like this. We're going to go over all the locations. We're going to see if a location is not connected to the orphanage. If a location isn't connected to an orphanage, then we're going to loop over everything other than itself. So, in fact, this probably should say lock A index here, where we look at a lock A index like so. Right? And then we're going to do a lock B index on the inside. And for any time that it's a different pair, so if we say if lock A index is not equal to lock B index, in fact, I don't actually need to do that now that I think about it. What I can do instead is just say grab location B if location B is connected to the orphanage. And so now I know for a fact they're not the same because they can't both be the same if one's connected to the orphanage and one isn't. So that's the same as also checking whether they're different. Then I'm going to take the distance between these two, right? And I should do a min-con A and a min-con B, so I'll store both of these. So then what I want to do is say if the distance between these two things, so if lock AP minus lock BP, and maybe I'll just call this the squared distance instead. So the distance squared equals the length squared of these two. If the min-con distance squared is greater than the distance squared of this connection, then this becomes the new best connection to make, right? So when we get on the outside of this, if the two indexes are not equal to each other, that means we found something we should connect. And so that means we will perform that connection and continue the propagation procedure. Otherwise, we just add the connection and call it a day, right? Make sense? Now I want to do an additional thing here, which is I want to change the color so we can see whether this actually had an effect. And now let's debug this part. Off we go. So here is our network. As far as we can tell, because I intentionally made those connections a different color, it doesn't look like it needed to do anything here. This was just a already fully connected thingamy, so no worries. Here's one where it needed to connect and it didn't. So that's an interesting problem. Let's figure out, look, what happened. So we obviously aren't doing what I think we were supposed to do. This was supposed to keep looping until we didn't find this. So what happened here? Let's reread this. I mean, we could step through the debugger, but first I want to reread it because I kind of hacked it out pretty quickly. Let's reread it to make sure that I didn't do something stupid first before we bother actually stepping through it. So we're going to go through all the locations here as lock A. we're going to add, increment by 1. So we're just going all of the lock A's, grab them out. If we detect that this isn't connected to the orphanage, then we want to find out who we might connect it to. So then we step over all of these, which are lock B's. We go over all the locations again. We look at the lock B, and we see whether, oh, well, that's it. Again, another typo thwarts a good routine. Twice today. Let's try that again. And hey, lo and behold, when you fix the typo, it actually works. So here we can see another set of connections between rooms, right? Where this bridged the gap that prevented our world from being, disparate, like bifurcated, right? Didn't need to do anything here. Oh, yes, it did. Right there. Didn't need to do anything there. Or there. How long are we doing this? All right, so we've got more time. Like, I basically accomplished more or less what I wanted today. I might add something now to thin out those connections that were too close to other rooms I was talking about, because I just think maybe making this graph look a little cleaner might be worth it in the long run. I don't actually know that it will, but, we'll see. So most of the time, this routine doesn't really have to do any work, but occasionally it just has to fix one thing. It doesn't really seem to fix two things very often, although I think we did see one case where that would have happened. We just haven't seen it since we added the routine. So presumably the random number generator can produce 2 islands off of the main island, but yeah, there you go. So this is a case where it had to do multiple things to fix it up. I assume that happens mostly when the numbers randomly pick lower numbers, so that like the density of things in the world is lower, so it's more likely that things are too far apart to be automatically connected by the simple like distance metric connector, right? So I think this is pretty good. It's producing things that I think are things I might want. The only thing I would say about it that so the only thing I would say about it from a game design perspective is that if I were a game designer, I might have a bit of a nervous energy about me. So this, for example, looks good. This looks like a game that you might play. As does that. As does that. And that, actually. This may be less so. And this probably not at all. So sometimes I think one of the problems is there's too many connections. Like, you may just not want to connect some of these things. One thing that I am interested to see, so what if we reduce the number of nav rooms? So first of all, let's get rid of nav rooms temporarily just to see what the connection graphs look like when you don't have nav rooms placed. One of my concerns is maybe there's too many nav rooms. That looks better, right? So I think maybe what's happening here is it's placing like too many nav rooms. So I think what I'm going to do is say, well, you know what? There's going to be a couple nav rooms, but like not that many. Maybe that's even too many. But I think like one of the problems is there's just too many of these extra rooms filling in the world a little bit too much. See, sometimes we do get sometimes a weirdness there. Like, why are we getting that? Like, it never seems to do that, and then once in a while it does, and I don't know why. We'll have to look at that. It's adjusted. It would still work. Like, the code will still run just fine, but it will produce a less than good placement, which we don't really want it to do. And so when I'm looking at these, like, I think with less nav rooms, you get a better... It just feels better. So I think that before our criteria for nav rooms was just a little bit wonky. So this was our criteria. And so maybe we say that it's between 4 and the dungeon count. So the more dungeons you have, the more nav rooms you have. But we ignore the item rooms, maybe from this. Let's see if that's a better metric. And I don't really know how to assess it, but like maybe that's just a little bit better. I also think that nav rooms should probably be forced to always have more than one connection. Because otherwise, what the heck are they there for? Right? So I don't know, we might want to go in, and if a nav room only has one connection, we add another connection to the next closest room that it's not, that it's like not in that direction that it's connected to, could connect to. I don't know. No, I wouldn't say a nav room to a nav room connection is redundant. I think that's okay. It's like going from an intersection to another intersection, and that seems okay. Yeah, and Technic Beam, I agree with you. So, Technic Beam, that comment is very true. It's kind of hard in Handmade Hero because I do it in these like limited chunks. The code's kind of messy, and the human factors aren't great. And that's just a problem with how stream programming goes. It's not great. It's just part of how the mentality of stream programming works. I agree with you. Like, if you looked at me programming normally, not only do I do stuff like the view always comes up with the same view that you closed previously if you did, but A, I almost never close the game anymore, and B, when I run it, the game they automatically open on my second monitor, right? So like I actually get the human factors way better when I'm programming on my normal day-to-day work. But like stream programming, it's hard enough to keep it on track when you do it only like once a week or these little blocks of time. You just kind of gotta not do some stuff. I mean, I don't know how to say it, but you're not wrong. If I was actually doing this in my actual day-to-day life, I would have fixed the zoom out, but you know, it just doesn't work that way, right? And stream. It's hard to say it. If you haven't done a program where you had to do everything on stream like this, which almost nobody does. So yeah, I don't know what we want to do. One thing we could do is we could force nav rooms to have connection. As MTS Mox just suggested, another option would be just remove nav rooms that only have one connection. I think that's a good suggestion because it means they weren't in areas that really needed nav rooms, so there's that. But what I would say is, in this case, Um, looking at this map as an example, as just a simple single example, if you looked at these, you would want to remove them. If you looked at this, you would probably want to connect it. So my guess is that maybe what we do is we do a pass over the nav rooms, and for every nav room, we look to see whether it could connect to something in the opposite direction of its inbound connection, right? If we can, we connect it, thus creating sort of a more like virtuous loop. If we can't, because like there's nothing in these directions, right? If we can't, then we just disconnect it and it's out of the graph, right? That to me feels pretty good. So I'm gonna try that. And what I'm gonna do is I'm gonna leave. I'm not actually going to remove the nav rooms. I'm just gonna remove their connections so that I can see that we did it, right? Because otherwise we'd never know. Like we wouldn't know the difference between whether this routine was having an effect or whether we just didn't happen to generate anything that had that particular, you know, sort of property to it, right? So let's suppose that after we're done, so we've already got a valid map now at this point, right? After we're done, we just do a pass over these where we look to see if this thing was a nav room. And we know, because we store the types in here, we know that it is, and that was important. That's why I did that, because we want to know like what everything is for later decision-making process. So if it is, we want to look to see how many connections it has. So in here, we'll just say, all right, for every connection, which is this code right here, so we loop over the connections here. We say for each of these connections, if con room A equals block A index, or con room B equals lock A index, con count gets higher. And then we'll just say if con count equals 1, then we want to like nerf, like we want to like remove this connection so this connection doesn't actually happen. And maybe we can short circuit that process by just saying like con index. This will be the remove con index. So if the con is 1, you know, then we grab the rem con index and we just say, okay, that connection now doesn't actually exist. Right? We just remove it. So let's see if that does the first thing we said, which is that now, like let's see if we can basically just get rid of orphaned connection rooms, nav rooms, I should say. So like that guy, right? He got removed, and that looks fine. This is maybe a little harder to detect. It's sort of the same circumstance, but it like. We may want it to be where it doesn't count if it's not another con room. I think, did somebody say that? I think somebody said that or something like that. I think somebody said that, and if so, I'm sort of agreeing with you here, but I don't. Anyhow, so I might say that when we do this, this is going to have to be a more complicated check now. So maybe we would say something like this. So here we would say, okay, if the connection is going to be to the, we want to get like the other room in the connection, right? So if lock B's type is not equal to world's lock nav room, then we count it. If it doesn't, right, then we don't. And this becomes a little bit more difficult because it basically means that we have to disconnect more than just the one remcon. So this won't work anymore. So we probably just want to do it this way. If the con count is only one thing, then we nerf all the connections that it has. So a little bit janky, but basically this. Okay, so that I think is correct. We're gonna have to watch that a little bit more carefully. It's probably not actually correct at the moment. So let's see. What is the problem? Assignment. Sorry, there was a single equals there. So we gotta probably go with the fine-tooth comb. Let me run it first to see what it does. But it's probably a little bit. There's probably some typos in there. So yeah, you can kind of see like it didn't really work, right? Like, that's not correct. I don't think that should be allowed to ever exist. Of course, it's kind of hard to tell because after we remove stuff from something, you know, maybe that's what's actually happening is you're seeing the removal order. So I don't know. That's a little bit harder. We'll see. But we just run through this one more time. So we run over the locations as loc A. We look at loc A and we say, if it's a nav room, we then count how many connections it has to things that aren't nav rooms by looping over the connections. We look at a connection, this particular connection. We say, if the room A is the loc A index, then we pull loc B from room B, which is the other one. If its type is not a nav room, we count it. We then look and see if room B equals loc A index, which these are mutually exclusive clauses. Then we grab room A instead and count it. If the con count is only one, so this is only connected to one non-nav room, we loop over all the connections. If either of them are this room, we nerf that connection. Right. I don't know, that looks right, but I don't know if it actually does anything useful. It looks like it just never does anything. I mean, I guess that one did get removed. This one somehow didn't. Oh, I know why. It has to be less than or equal to 1, because it might be 0 now, which it never could have been before. But now that we're only counting nav rooms, it might just be 0. Okay. That was just a typo. Interesting. So actually, not quite, because that actually was a very valuable nav room that we deleted. Right? So I think we maybe don't want that. Like, maybe that's not so good. Like, maybe we do want to just count any of the rooms. I mean, I guess we could try to classify them as interior or exterior connections. But I'm just not sure it's worth it. So we may just want to say, like, nah, it's fine. Look, if either of them are the thing, then we ink it. And we just remove ones that only had one connection. And maybe that's just what we do. And occasionally we do get exterior stuff, but that's the price we pay for being able to do stuff like this, which would otherwise have been removed. And maybe it's worth coming up with a metric that checks to see whether we would be breaking a valuable connection by removing the rooms. But I just might maybe when no one would care. Like, it might absolutely be throwing tons of code at a problem that just doesn't actually exist, right? I would love to know why sometimes we're not able to generate points in the analysts here. If that's like just some kind of a overzealous dungeon count kind of a thing. I'm not sure, but we'll deal with that crap later. That's sort of a separate issue. That's just a point picking issue. So I feel like this is now pretty nice. Like, I'm pretty happy with this. I'd say maybe now we don't add those kind of lines anymore. So what I'd like to do is when we go to add the default connections, so it's this thing here. When we do this, I would like to look to see whether or not this line passes too close to any other room, right? So like I just want to like make sure we don't have things that pass within a certain like radius of another room. So I want something like, you know, closest point, you know, distance between line and point, that kind of thing. So I basically want to say, like, if I were to take the points A and B and draw that line, then I want to make sure that that line and then the point of some other location, C, I want to make sure it never passes too close to those things. So in here we've got a lock C. And again, I don't really know that I need this, but it's pretty trivial to add just as a little test to see. So I'm going to do it. Or two viable So effectively what we're going to do is find the squared distance between these things, and I'm going to look to see whether it's within a certain radius. And I don't really know like what the radius should be. So for starters, I'll just set it to 10. But I don't know. We'll look at that later. Anyway, so what we would do here is say, okay, we're going to loop through the things. We want to make sure we're not going to test anything that already exists. So we want to say, or that's part of the system. So if lock A index is not equal to lock C index, or maybe I should say if lock C index is not equal to lock A index, and lock C index is not equal to lock B index, then I will test it for viability, and we need a distance between line and point thing, right? And it's really a line segment. So in the math side of things, we just need this routine. It's a pretty basic routine. So what I want to do here is say if I have line 0, line 1, and then the point, we're just going to look to see, oops, that's supposed to be a V2. I don't know why I typed F32. We want to try and produce like what the closest point is to what the closest like distance is from this line segment to like to the point we're checking, right? That makes sense? So really, I mean, this is a pretty simple routine. The only problem is I can't offhand just thinking about it in my head, I don't immediately think of a way to do it without without a square root. Which these days isn't really a big deal. Square roots are not expensive like they used to be. They're pretty cheap. But I'm just thinking it through in my head, and I'm like, my normal approach to this would probably be to just normalize the line segment vector. And then you can produce the entire thing from that. Very trivially. It's like a dot product and some min max stuff. So I think I'll probably do that. This is not going to be a performance thing for us anyway. But it was just amusing in my head. I was trying to think through, like, is there a way to do this without ever normalizing that vector? And I don't know. But so I'm going to do the version with the normalized vector, because why not? Okay, so the normalized vector version is very simple. It's basically just if you take the... So this is the one point on the start, like, of the line segment, let's say. This is the end of the line segment. You don't have to think of it that way. You could think of it as running the other way if you want to, but just for the purposes of this computation, I'm thinking of it as starting at L0 and ending at L1. But you could just swap those two. It wouldn't matter, but it doesn't matter at all. And so then what I want to do is normalize that. So I want to take this and normalize it. But I kind of don't want... I probably want to leave that around. So I'm going to call these some different things just so we can see what they all are. So I'll call that the delta. I'll call the delta length exactly that, right? And then I will take the direction as the delta divided by the delta length, like so. I think we force ourselves to do it this way here, which I don't really know why these days. It's holdover from the old days when you really didn't want to divide things. So we're going to take the delta between the 2 points. We're going to see how far that is, and this is the square root in here that's happening. And this now also, by the way, doesn't actually need to be a squared one anymore because we're going to actually end up with the real length. I believe, although I guess we could leave it that way. I mean, I could, yeah. We now can produce the actual length, not the squared length, if once we do this one operation. But yeah. Anyway. So if I take the direction, then I now know a bunch of measurements that are easy for me to produce with P. So I can say the, like, you know, relative P is going to be the vector from L0 to P now. And I know its distance from this line very trivially. It's the perp dot product, right? So I could very easily now, by taking just the perpendicular dot product of this vector with my direction vector, that is the distance between the line. Now, the reason that I can't literally just do that, so the reason I can't literally do this like that's the actual answer to that question. Meaning, if it was actually a line, the mathematical sense of line, where the line extends infinitely in both directions, then this would be correct because this is the distance from that line to the point. The problem is, this is a bounded line. The line starts and stops at those two, like L0 and L1, right? And so we don't actually want to take the perp dot product with this because we need to clamp. That would produce erroneous answers. It would say like a point that's really far away from this line segment, but happens to lie along the line, if extended, would show up as a very small distance or even 0. But it's actually very far away, right? So the reason we can't just directly take the perp dot product and say, well, there's the distance, that's the distance of the line. So what I need to do is first bound my answer by the 2 endpoints of this line. So what I'm going to do there is say that rather than taking the perp dot product, I'm going to take the regular dot product. And that's going to give me the t value that is along this line, this direction. How far would I go to get to P, right? And so at that point, oh, schmutz. I can do it with that. I'm so rusty at this stuff. You know, I used to program 3D all the time, and I don't anymore, so my math just gets rusty. Never mind. We can do it as a point squared without this. It's actually not that bad. Forget all that. Just take the delta, right, between the two. Take the inner product. This t is the distance along this delta you would travel to get there, right? That would just give you the correct answer. Oh, no. Okay, no. All right. I thought I was being bad. No, that's not true, because the length of rel p would still be in there. I thought for a minute that I was really being dumb. I was like, gosh, like, how did I think I needed to do that? But no, I think I'm still right, because without normalizing direction first, then I don't actually know the distance along that direction, because rel p, its length would be included, right? So, yeah, you know. All right, so if we know how far we're going to go along it, we can then clamp this. So we can just say, like, all right, let's go ahead and clamp this between 0 and the length, the actual length. And here's why I was thinking, like, that's why I was thinking, like, well, I'm kind of wondering if I am still right. I'm just so rusty at this, you'll have to forgive me. Because so what the inner product will give you is the length of the two vectors times each other times the cosine. Of the angle, right? Of the spread angle. So if you then multiply distance, it's just going to multiply out. I don't know. I'm going to go ahead and try the thing, and we'll see. We'll actually test it. I feel like I actually am possibly correct. And my brain's just very rusty at this, so I can't promise you, because I just, it's hard for me to think through these, like, words that used to be second nature. When you stop doing them for a long time, they cease to become second nature, and you have to actually work them through again. So I want to say that that's actually just it. And so then you would just say, all right, the closest point, is just, if you clamp that between 0 and 1, then the closest point is L0 plus t times the delta. And so then the result is just the length squared of that. Right? So could be wrong about that, but I feel like I'm not. So I think that just ends up being the correct answer. We need to kind of test this routine, though, because that could just be garbage. But yeah, if that routine actually worked, then what we would expect to see is less of these things. So that's not actually working. Like, you can see that that connection is still being added, which it shouldn't be. So, we're not out of the woods yet, but this is basically what I want. So yeah, so we have first of all, we don't really know if this is iterating over the correct things. That's kind of a little bit of a problem, because, we do want this routine to properly produce all combinations. And I think this looks roughly correct. And you know what? I probably should do it this way, too, at first. So I should probably also say, we're gonna add them still, but we'll add them as green or red connections or something like that, right? So that we can see if we get this thing working, if it will actually remove ones or not. That needs another parentheses. So we take the line segment that we're given, we take the relative position, we do the inner product between the two and clamp the result between 0 and 1. We then produce the closest point, look at the length of that closest point between there and the actual p-value that we're passed in, and return the result. That looks pretty good to me. So we'll have to debug that routine. And this looks fine. So I don't see the bug immediately. It could be that my math is just too rusty here, but it also could be that we did something else wrong. So what I need to do now is create a favorable, like, debugging thing. Because, like, what I want now is a way to step through the code for a situation like this, where we have one that we know is wrong. So, I kind of want to I want to like create a thing that makes that explicitly and only that, so I can step through and see what's actually happening. You know what I'm saying? Muted? I'm muted? I don't actually believe you. Wheel, I don't actually believe you. I think you have lost audio. I think your computer has crashed the audio. So I think this is maybe the last thing we'll do today. Let's take a look at this routine and see if we can make it sensible. Which is to say, if assuming, well, let me broaden that a little bit. We want to figure out why this isn't removing connections that we think it should be removing. That may be because of this function, but it could actually have nothing to do with that function. So, we'll see. Yeah, I think so too, but I just wasn't sure about that. I need to think it through a little bit better. I don't think what you're saying, though, is quite right. I mean, think about it this way, right? So suppose we've got that, and we'll ignore this part of it temporarily. So suppose that I said that I wanted, like, what we did before. I said, okay, the direction equals delta over length of delta. Right? So I'm saying that we've got this direction. If I then said, well, okay, I want to take the inner product of the relative p with the so then I produce this t value here, which is the inner product of the direction with the relative p, right? Then what's the actual t value here? Well, the t value is going to be how far in this direction I have to go in order to get to the perpendicular placement for rel p, right? Now, the problem here, and so that's actually good, but the problem here is you wouldn't clamp 0, 1 at that point. Right? Because clamping between 0 and 1 is not going to tell you... you need to clamp between 0 and length of delta, right? So I suppose this actually properly clamps it to the line, but what it doesn't do is find the actual perpendicular. Right? Which is kind of unfortunate. If that makes sense. So what I was thinking in my head is I was like, well, you could just eliminate that by just not doing the divide. And then you do get this, which is correct, except it's no longer the perpendicular location. Right? So the question is, could you have done anything else there? And I don't think you really could. So I think my first instinct was probably correct in that I had to do this. And unfortunately, this is kind of annoying because you would prefer that if you didn't have to, right? You'd prefer to not have to do this if you could avoid it. Right? Because it's definitely more expensive, but And then your clamp has to not be a clamp 0, 1. It has to be an actual clamp between 0 and a real value. But I can't think of any other way to make this be the perpendicular. That's the problem, right? The clamp would have worked. It would have clamped to the actual line segment, I think, but it wouldn't be the perpendicular location. Because it would have gone out. Instead of going the distance it should go to the perpendicular location, it would go the distance it needed to go to the perpendicular location times the length of the direction vector. Right? So I can't quite figure out a way. So the clamp would work, but it wouldn't be at the perpendicular, so I can't quite figure out a way to do it without that divide. And there may not really be a way to do it without the divide. I'm not saying that there definitely is, but I can't think of what it is because I do think we would not produce the perpendicular in that case. So I don't know. That is sort of what I was typing in the first time. This is what I was typing in the first time, and we may just have to do that, but I don't know. Anyway, so now we have to debug it though because it still doesn't work, right? Like it's still not actually producing the results we want there. Let me make sure that I wrote the rest of this correctly, I suppose, but you know, it's still not quite correct. So assuming that we clamp this thing, oh, nope. No, wait, no, that's correct. So now we produce the direction, which is the normalized version of the delta, which is what we would expect. We did the inner product. We clamp it between, you know, the two bounds, right? And then, oh, yeah, and then this has to be the direction. And then we're good. That looks pretty good, right? That seems to have identified exactly the kinds of connections that we're talking about. So I guess I should have typed it in the first way I was going to type it in first. I'm trying to be a little too clever there, but oh well. Looking pretty good. And like I said, we could make a larger radius to get rid of these, but I don't think I want to get rid of those. I think I want to leave those in. Meaning I don't mind crosswise connections. However, I also don't know how big that radius should be. It could be that we do want it larger than what it is. So that I don't know. Like maybe this wants to be 20. I'm not sure. So I don't really know, right? But, you know, so you can see here that one probably would have been fine before, and now with 20 it's not. And, you know, is that bad? Again, I just don't know. And so maybe we'll just say, well, we know, you know, it's there now. And, you know, it's there now, and we can change that value, right? Like we can tune that value to something else when we want to. So I think that's it. I think we're done. Great. I mean, I really like these maps that it's producing. Like, I feel like this is a pretty good thing. And like, I'm pretty happy with that for 1 day worth of doing stuff. I mean, 1 day, 2 hours. For 2 hours worth of stuff, that came out quite nicely. Oops. I don't know why I did that. So I'm really happy with that. That looks good. It's a very simple algorithm. There's very little in it. It's easy to understand and easy to add things to. So I think that's great. That's, you know, I think that works for me. Congratulations. Good work. Everyone's done. One thing you do want to do is mark rooms here as like deleted, sort of. So I'm just going to mark this as a world lock none. And that way it'll just get skipped, so it will not get created in here now. And that way we won't have any rooms with no connections because, you know, we removed them, right? So, what's up with the box no connections? So what we do is we start out by creating a completely connected map. I probably shouldn't have done what I just did until I explained this. Let me explain it again. Because we've reached the end of the stream, so I can explain that because we're basically done. So let me remove the part where we get rid of those rooms so that they will still show up. The rooms you were talking about, I just removed them, so I wouldn't have been able to demonstrate anything. Like it's like this. So what you see here, these rooms are color-coded based on what kind of rooms they are. Red rooms were going to be monster-oriented things that we wanted in there. Yellow rooms were going to be dungeon-oriented things. Blue rooms were going to be item-oriented rooms. So these are just things we were playing with the game design as we're going to do it. Like, it's just going to do a thing that we do, right? But we also added these green rooms, and green rooms are not actually like rooms that have a gameplay significance in the same way that the other ones do. Rather, what they are is like navigational waypoints for the player. So they're things which are serving as connections that do not actually themselves contain something like an item, right? And so when we do that, what we found was sometimes, like this room, for example, before I added the removal thing, this room would be added and there'd just be like one connection to it. Like probably the way it was before the pass, there's a pass that removes these, is it would just be one connection here. We didn't want a lone room like that. In fact, I can put even that part back in. So it's this code right here. So I'm going to nerf that entire routine, and you can see what happens. So when I create something that has one of these, like, okay, so here. So this is a nav room, ostensibly, but it really doesn't do anything. Like, unlike the purpose of nav rooms, which is to serve as, like, connections between regions of the map, like here, here, and here, this is literally just a dead end. So we didn't want that. So what we did is we added a thing that would remove those rooms by finding them, which are nav rooms that are only connected to one thing, and then removing them. Now, we didn't want to actually remove them because I wanted to see whether this routine was working. So what I did is I just removed the connections between them first so we could see that our thing was working, right? So there's one right there. And so then the final line of code I added was just the thing that actually nerfs the room. So now when we put in this line of code, which says, hey, if you detect one of these, just get rid of the room as well as its connections, then you get this. And now we just have just what we wanted, which are things that provide connections. But if it wasn't actually providing connection between two rooms, if it wasn't providing some alternate path between two actual gameplay locations, that you couldn't have otherwise traversed without it, then we get rid of it. And so that's what was happening there. It was sort of the reason they were still showing up is because I wanted to leave them in so I could make sure I saw that that routine was working. Whereas if I had just deleted them, I wouldn't have known. Maybe they just never got generated, and I wouldn't know if it was actually working, right? So, will the world still be infinite? No. Well, the world was never supposed to be infinite. I mean, that would be a kind of unsatisfying game to play, probably, if you could never win. So, yeah, like... Would it correctly remove a least sequence of multiple nav rooms? No. If there are multiple nav rooms, it would not remove a cluster of nav rooms. Or, for example, like, you could argue that maybe you want these to be collapsed down to fewer nav rooms or something. For the moment, those are left in. Right? Because one way to interpret this would be, like, you shouldn't have nav rooms that connect to each other. That should just be, like, one nav room or something. I mean, maybe. But, like, you know, it's too early to say whether I want that or not. These maps also look pretty good. I'm pretty happy with these. So I have smooth transition between rooms or the player teleport between rooms. Well, it always smoothly. So rooms are always. The camera always continuously pans. If you've seen, before we deleted the other rooms that were here, which we're now going to replace with this different thing. You know, presumably, if you've ever seen that, you know that the camera smoothly moves between things. But in some circumstances, we do plan to lock the player. Like in the dungeon areas, the player will be locked in a room till they solve that room in the traditional Zelda Binding of Isaac kind of paradigm. So, oh, well, these are just locations. We're calling them rooms for no particular reason. They're just locations. This will all just be one continuous overworld map. But what we were trying to do with this is just where the locations of interest are, right? So all of this will just be continuous forest throughout all of this. And what, you know, we will be generating like trees and stuff that produce a boundary that looks roughly, to a first approximation, like this. Right? And one thing that we probably will do, and maybe could do, in fact, we could do this next week, is any connections that are too long could be subdivided as well at this point now to add weird other notational things we might want in here, right? So we might want to put more things in here or bifurcate some of these, right? We may do decoration now at this point at a finer grain level to figure out what else we're going to produce in here. But this is just the higher order semantic structure of the world. Almost like if you were to read a map, this might be more like what the map would display, right? These are the important locations of interest, if that makes sense. All right. I guess a way to not have square root is to not normalize, do the inner product, divide the result by length squared delta, clamp 0, 1, and multiply t by delta. Yes. I do think we could avoid the square root because you could carry the distance through on... It's just the divide you can't avoid. So I agree. Like, if you did the inner product here and didn't normalize it, you would still know that the length is then multiplied into this. So you could multiply the length, you would clamp it to between 0 and the multiplied length. Then you would do this and divide this by the length because it would be included, right? So I think you could do that, but I'm not sure that it really matters all that much. I was just trying to see if you could do nothing, like if you could do only multiple. Going from fmads to divides is just kind of bad. Square roots are not any really worse than a divide. They're basically the same most of the time. They're not super different. So, like, you know, once I'm in that zone, I tend to stop thinking about it too much. But I agree. You could totally do better. You could minimize the number of divide / square roots. Right. So, like, if you look at those two things... So if you look at these, you've got like squirt PS. Can I get Zen 3 in here as well? All right. So yeah, if you look at a squirt PS, you can see like the latencies for these things. You got to ignore the memory ones. So if you look at just the register ones, you can kind of see that they're just not that expensive. That's reciprocal square root. This is regular square root. I mean, it's still it's less than 20 cycles, right? So it's like, and you know, you can do other work during that period. It's just really not that big a deal anymore, because it's all overlapped. It used to be that it was like the whole processor was stalled for like, you know, 40 cycles or something while it did this stuff. Divs are cheaper. They're going to be like, you know, not as bad as that, but they're still kind of in the same ballpark, right? You know, 10, 12, or 10. So you pay a little bit more maybe for a square root, but, you know. And they both have faster versions. So like reciprocals, you can, you know, are much faster. And same with reciprocal square roots, much faster, right? So you can also, if you don't care about the exact quote unquote in IEEE sense exact answer, you can trade some bits of precision for much faster in either case. So at some level at that point, I'm just like, whatever, right? And you know, so we if we ever care about that routine, we could definitely do a better job. But all right, so that's about it for today. I don't think I have anything else to say other than yes, we could simplify this quite a bit, right? You just would basically not bother taking this length. You would leave the length multiplied in, because when you do this inner product, it will just be in there. And then at the end, you divide by that to fix your, you know, the fact that you've got the wrong, scale, basically, right? You would just divide You just divide this right here by the length that you took, right? And it would then have, of course, it would still have the additional length in there, so it's not exactly trivial to do. But again, you just write the math out. The point is, instead of just looking at it like this, we would actually just go write it out. And this inner product is it's the length of this times the length of this times the cosine of the angle between them. And only part of that do you want. You want the length of this times the cosine of the angle. That's what you want. So you just leave the other length in there. You know it's going to be in there. So you just need to make sure that you can make it cancel out by, adding a squared term, by multiply that by the length and then divide by the squared length or something, right? You just have to do something to make the terms cancel out for the math that you actually want. I think the answer is you can't do it to get rid of everything. You will have one divide, but you could get it down right here. There's a square root and a divide, and you could get rid of one of those, right? Is I think the point. You could leave this length as being squared or something, right? You could do something like that, probably. But again, that's all. That's all we're talking about. Okay, that's it for today. Let's go ahead and wrap up here. Somebody, and I'm sorry I missed this comment, somebody mentioned sorry to disturb the train of thought. Meow finally arrived this month, and we loved it. Any hints on when the next volume will be out? That is somebody asking about Meow the Infinite, our comic book series we do at Molly Rocket. You can see it here. If you go to meowtheinfinite.com, actually, you can see it here. And I'm really glad to hear that it arrived. We ship them out, but a lot of people, we get a lot of, because a lot of people watch the stream from overseas, not in the continental U.S., shipments sometimes take a very long time. We may ship something and it doesn't arrive for like a month because we're shipping it, it's shipped to Australia or something, right? And just the shipping takes a long time to get there. So sometimes we usually ship things out within a few days of anyone ordering it, usually like the next day even. But sometimes it takes a very long time to arrive, just the same. But either way, I'm really glad to hear that it arrived and that you loved it. We put a lot of work into it, and it's really nice to hear that. We don't get a lot of feedback on these things. We mail out all these books. We've mailed out hundreds of these books. At this point, I guess we've mailed out literally over 1,000, because if you count both Volume 1 and Volume 2, we've mailed out a lot of these things. But we don't hear much. We don't really know. We just know that people buy them, but we don't know what they think. Sometimes we get feedback from people who really like it and take the time to tell us, and we really appreciate it. So thank you. And in terms of the next volume, we're not sure exactly how it's going to get released right now, because we released the digital editions first. And this final volume, this is the last. There's only 3 books total in Meow the Infinite. Originally, there were only going to be 2, but book 2 would have been too large. So we had to split it into 2, so it ends up being 3 total books. There's a lot of stuff in book 3, and it's not obvious how you'd separate it into chapters, because if you read books 1 and 2, which sounds like you did, then I think I don't want to spoiler anything for people who haven't read the comic and might want to. There's a reason why book 3, you know if you finish book 2, why book 3 can't use the same chapter structure as the previous books, right? So we have a bunch of book 3 done, but we're not sure exactly how to release it in the digital edition yet. But we probably will release some of the digitals before the print edition, because that's what we normally do for people who have the digital edition. So that'll probably get released earlier. As for when book 3 as a printed volume will be out, it won't be till next year. The reason for that is just we have a lot of work to do. And so Meow, we don't spend all our time on Meow the Infinite, right? It's just one of the many projects we have, and we're very small. We're a 2-person team, so it's kind of hard for us to get to everything. So we're trying to get there. It's partially done, but it won't probably be completely done until next year, because it's big. I think our estimate for book 3, because the layouts are mostly done, and a lot of the, like, probably a good 30% of the actual art is actually finished. The estimate's around 300 pages, so it's actually longer than the other 2 books as well. Book 2 is longer than book 1. Book 3 is longer than book 2. And that's just because there's a lot of story in this thing. As you know, if you read Meow the Infinite book 1, and then you read Meow the Infinite book 2, you kind of know that, like, the story complexity keeps kind of ratcheting up, and you realize that, like, okay, book 1, there was a lot more going on than I thought there was. At the end of book 2, you're like, oh wow, there's a lot more going on than I thought there was. So book 3 has, like, all of this stuff that has sort of been put into place by the first 2 books, and it kind of needs to have all of that. It all needs to be there. We can't, like, get rid of any of it, because all of the previous books were sowing those, like, seeds, right? And it would be kind of unsatisfying if we just cut stuff out to make it shorter. So book 3 is about 300 pages, which is longer than either 1 or 2. But like I said, it's got a fair bit of it drawn already, and it's basically all written except for 1 or 2 scenes that I have to go finish. And so, you know, it's well underway, but it's not probably gonna be done this year because we have so much other work to do. If we were working on it full time, it would be done this year, no problem. But we just have too much other work to do that we can't afford to do that. I mean, one of the problems with comics is they don't make a lot of money, right? Even if we sold out the complete stock that we've printed, you know, this project just doesn't make very much money. Comics just aren't a big business, for anybody, really. You know, it's a bigger business when you think about making them into movies or something that can generate more revenue. But they're not in and of themselves. It's pretty hard to make much of a living off of comics. That's not, you know. So we can't usually prioritize Meow the Infinite as, like, what we work on every day, all day. But we always find enough time for it to move it forwards, and like I said, it's nearing completion. So I do think 2023 will be book 3. You'll see a Kickstarter in 2023, I think, for that print run. And you know, we typically have the thing printed a few months after by the time the Kickstarter closes, it's only a few months before we start shipping out books. A lot of times it's, you know, if there is a snafu like there was this time, it's on the printer side, not ours. So, you know, we're usually pretty good about that. When we do the Kickstarter, usually the entire book is almost ready to go. So, what other projects are we working on? God, I mean, I've got 4 things that need to get shipped on my hard drive, right? And they're kind of sorted. I mean, 5 technically, if you really want to talk about what needs to get shipped. So I literally have like 5 entire separate projects that need to get shipped on my hard drive. And so right now we're just working on getting them out in the order of simplest, like least difficult one to finish, in order, right? So that's what we're doing now. We want to ship 1 thing this year, and maybe 1 next year in addition to Meow. So we're hoping by the end of the year we'll have 1 thing shipped, and then next year we hope to have another thing shipped out of those projects on the hard drive. There's no way we're probably going to get 2 of them in 1 year unless I magically become 10 times better at programming or something. So the print quality is second to none. It looks so good. Yes. Thank you for saying that. We're very proud of the print quality. And we worked very hard to get that. We do way more pre-press work than almost anybody I know, and I think it's incredibly difficult to find comics with as consistent print quality as ours, and that is just because we work incredibly hard on that. Way harder than anyone I know. I pick up books from major publishers, and the print quality is garbage. So, you know, it's like we take it way more seriously than almost anybody. I'm sure you can find some other people who do as well. Like once in a while you can find someone who's like, okay, these people cared a lot about the print quality, right? You can tell. But the vast majority of like graphic novel or comic work, the print quality is really not very good. And we really wanted to be like, when you pick up a Meow the Infinite, we wanted it to be as good as the best print quality that you have on your shelf, right? And we worked really hard to get that. And I think we succeeded, because it's really hard to find, you know, you can find books that look as good as Meow the Infinite print quality wise. I don't think you'd find many that look like significantly better, right? And you can find a lot that look a lot worse. And that's just plain old work. That was just elbow grease. Working closely with the printers, redoing panels, being really meticulous about the CMYKs, poring over proofs very carefully and redoing them. I mean, it was really a lot of work, and mostly on Anna's part, because, you know, she's the artist. So, you know, I can look at these things and help scrutinize, but I can't fix it. So it's a lot of work on Anna's part. And then it's, of course, me like talking to the printers and being like, I want this fixed or whatever, right? But it's mostly Anna. And she just put a tremendous amount of work in to correct the proofs to get them to what you see. So thank you for saying so. We really appreciate it, because we put a ton of work into making sure that the print quality would stand alongside like the best books you've got. And it's not easy. The way easier thing to do is just dump the RGBs to a printer, and then the book looks too dark, and the text is a little fuzzy, and the registration's not great, and all this other crap. That's the easiest thing to do, and you see it all the time. But when you get someone who cared, you know, like when you look at the book, you're like, oh wow, this is so much crisper. Like, it just looks, and it's not all muddy. Like, it just looks good, you know. And you can tell that's someone who did a good pre-press, you know. And it's just it's literally just elbow grease, and working closely with the printer. So yeah, Meow the Infinite. Order your copy today. A bargain at $40, which most of which is shipping. This is the bane. Like, we could offer these so much cheaper if it wasn't for shipping. Oh man, this is why digital work makes so much more money. It's the frickin' shipping, dude. Like nearly 50% of the purchase price of these things is literally just shipping. You know, packing materials, post, all that stuff. It costs vastly more to ship these books. It costs easily twice as much to ship these books as it does to print them. Think about that. So, like, literally, like, shipping a copy of Meow the Infinite, it costs like twice as much to ship it as it did to print it, usually. So, you know, shipping. It's what makes it tough. We'd really like COVID to be over so we can go sell these at conventions, which it seems like now is going to be a thing, because that's way easier, because then the shipping is us piling a bunch of them into the back of a car and driving to a convention somewhere where you can buy them, and we could offer them for less money there, because now the $12 or whatever it is that was literally just going directly to the post office, you know, doesn't have to happen, right? So all of a sudden a $25 book can become a $15 book or a $10 book, right? And we still make some money off of it and can pay the printing and all that. So yeah, you know, shipping, it makes it hard. It's the hardest part of selling of a comic for sure. Is the shipping is just rough. So anyway, yeah, Meow the Infinite. If you like comics, it's a comic with a lot of heart. It's a pretty interesting story. We put a lot of thought and a lot of love into it, and if you like comics, I think you'll like it. It is an all ages kind of thing, so you know it doesn't have a lot like violence and sex in it and stuff like that. So it's definitely, if depending on what your comic sensibilities are, you know, if you're not into more of a story for the whole family kind of a thing, then you might not like it. But you know, assuming that you like, you know, assuming that you might like Toy Story, right? Then Meow the Infinite, I think, is pretty darn good. If you don't like Toy Story, then, you know, not so much. Because it is kind of in that zone, right? So. Does violence and sex improve things? It depends what the story is. Sometimes it does, right? Sometimes you're in the mood for a gritty thing. I mean, you know, if Game of Thrones didn't have violence and sex in it, do you think it would be better? I doubt it, right? So it really depends on what you're in the mood for. If you're in the mood for Game of Thrones and someone gives you Toy Story, you're not going to be very happy, right? So anyway, that's it for today. Thank you so much for joining me. I will be back here next weekend to, I guess, we'll start filling in actual entities along this thing, because I think we've got enough superstructure filled in for the world now that we don't really need any more meta information. So now we should be able to start actually filling in forest, and we'll probably do like a really crappy forest first. Like we'll literally do something where it's like we literally just have large empty corridors of forest that connect the rooms of the forest, right? Like we'll do something super crappy first, and then we'll play the game a bit in that sense, work on it, and then we'll come back probably much later to greeble it up so that it doesn't look so obviously like big quarters. But we got to start somewhere, so we'll take this meta structure that we have and we'll sort of make the first pass crappy version. We'll go. Off we go. What's the last? Why didn't you do this generator backwards like with the witness grass? Backwards. Whew. What does that mean? Do this generator backwards. I don't know. I didn't do it backwards, but then again, I don't know. I didn't think of the witness grass generator as being backwards either. Creating the connections first. How would you create connections if you hadn't created things that you connect? Also, what does that have to do with the witness grass? The witness grass creates the grass. Do you just mean the order in which you do it? Meaning, why didn't I put down something and then go from that thing and look in a radius around it to place things? Is that what you mean? So rather than backwards, do you mean like in a forward, like going forward? Yeah. The reason is because we don't know what we want yet. So if we knew for a fact that we could generate things conveniently that way, right, then that's a reasonable way to do it. In the case of witness grass, there's no such thing as connections between grass, right? So it was just a straight blue noise pattern, so you know you can do that. It's trivial. In this case, we don't know what the criteria are, right? This is just the first pass, and even now we're already doing things that maybe wouldn't be so obvious how they would be placed in that system, right? Because remember, we've got all sorts of things in there, like certain things have to be further away from other things than each other. Like there's different types of rooms in this. The witness just has one type, right? So we don't know what we need to do. So we don't want to go for an optimized wavefront builder when we have no idea what we're actually building. Eventually, when we're done. So when we have worlds that we are happy with and the whole game is playable and we're like, great, then we definitely could go back and look to see whether there's a wavefront single pass, like in The Witness, a single pass wavefront, that produces the same output, but it's way premature to do that, right? That's an optimization. Because the way you have to state things in that system is very non-obvious. You can't just arbitrarily throw constraints in like we're doing now. Like, the multi-pass version is way better for development because you're just like, I don't know, let's put in a pass that removes single rooms or whatever, right? And then you just do that, and you just slap them on there as they go. That's what you want when you're just experimenting, because otherwise it becomes too cumbersome because you have to make everything work inside this, like, Procrustean optimized wavefront expansion, right? So you have to be really careful, like, when you choose certain things. When you're working in experimentation, you want as close to a declarative model as possible. You want something you could just throw crap in and say, okay, I'm going to, like, just add another pass here that adds some things I need. And you don't want to have to think about how to integrate that into a complex system. You want to just be able to throw it on top and not care. So that's why the different approaches. If all we were doing is just generating blue noise points, I probably would have started with a wavefront for sure, because I know that works. But because I don't actually know that that's what we're going to do long term, like, I really just don't, because it's game design, right? It's got to be flexible. I don't want something tight. I want loose, right? I want code I can play with that just kind of does stuff, where we can explore possibilities and not have to think about the performance or constraints related to the fact that it's engineered for performance. So that's why I just don't care about that stuff right now. But we might care later. We just don't care right now. Hopefully that answers the question. All right. That's about it. All right. Thank you, everyone, for joining me for an episode of Handmade here. It's been a pleasure coding with you, as always. Until next weekend, that's about it, folks. I will see everyone back here for some more procedural generation. I feel like we did a good job on these maps this is a pretty good algorithm for just throwing crap in and getting reasonable maps out. So I think we're good to go. I don't think we're going to have to think about this for a while now, because really, like, we're going to probably want to think more about the room-to-room gameplay for a little while now, because, like I said, we're just trying to get a first pass in here. Until we actually play more room-to-room stuff, we probably won't have to think so hard anymore about, like, the meta structure, because that's going to come together more as we start to go, like, wait, we see these little gameplay things and we want to reinforce them with the meta structure. We can go back out there and do that. But for now, we just need a reasonable things that look reasonably like maps to start playing on, and that's what we've got. So I think we're good. All right, that's about it. I'll see everyone back here next weekend. Until then, have fun programming, everybody, and I'll see you on the internet.